It really feels like something fundamental has shifted. For decades, AI was this slow, steady march forward. But in just the last few years, it's felt more like a Cambrian explosion of intelligence. A sudden, massive leap in what machines are actually capable of. So let's dive into what's really happening.
And just like that, it's here. Suddenly, you've got models like Google's VO that can take a simple sentence, a majestic horse galloping on a beach at sunset, and poof, it turns it into breathtaking cinematic video. That huge barrier between a creative idea and actually making it, well, it's just dissolving right before our very eyes. And then suddenly, you look over at the world of science, and DeepMind's AlphaFold cracks the protein folding problem. This was a puzzle that had biologists stumped for half a century. And now it's accelerating drug discovery and our basic understanding of life itself. It's just incredible. And if that wasn't enough, suddenly, tens of millions of miles away on another planet, NASA's Perseverance rover is using AI to navigate the Martian landscape all by itself. It's making its own decisions in a place that's way too far for us to control in real time. So from art to science to literal space exploration, the whole game has changed. Okay, so this brings up a huge question, right? An explosion like this doesn't just happen by accident. It wasn't just one lucky discovery. So what on earth actually lit the fuse? Well, the answer isn't magic. It's more like a recipe. It's the moment when three incredibly powerful forces, three distinct pillars, all came together at the same time to create the foundation for this revolution. This whole revolution is really built on three crucial pillars. First, you've got exponential growth in raw computing power. Second, a massive, and I mean massive, deluge of data for the AI to learn from. And third, these brilliant new breakthroughs in the algorithms themselves. So let's break them down one by one. First, let's talk about the engine of this revolution, compute. We're talking about the sheer, raw, computational horsepower, the brute force that you need to train these gigantic AI models. Now, to really wrap your head around the scale of this, get this. Some of the biggest AI models trained back in 2020 used a staggering 600,000 times more computing power than a model that was considered groundbreaking just 8 years earlier in 2012. That isn't just growth, that's like a different reality. And this chart really visualizes that insane growth. Since 2010, the amount of compute used for top-tier AI training has been growing at a rate of 4 to 5 times every single year. It's this steep, exponential curve, all thanks to specialized hardware like GPUs and TPUs, which are just perfectly designed for the kind of math AI needs. Okay, so on to our second pillar. All that incredible power needs fuel, right? And for AI, that fuel is data. We're talking about the vast digital ocean of text, images, code, and just information that humanity has been creating for decades. Think about a model like GPT-3. It wasn't just fed a few books. It was trained on datasets with over 1 trillion words scraped from the internet. It learned grammar, facts, and all the weird subtle nuances of how we talk, simply by finding patterns in that colossal mountain of information. And that brings us to our third and final pillar, the blueprint, the secret sauce that makes it all work. Because you can have all the computer power and all the data in the world, but without the right software, it's just a bunch of noise. This is where the brilliant new algorithms come into play. And this slide illustrates the shift perfectly. The real eureka moment was the invention of the transformer architecture back in 2017. Before transformers, AI was mostly rule-based, kind of clunky and brittle. But transformers gave AI the ability to understand context, to see how different words or pixels in a sequence relate to each other. And that unlocked the true potential of all that compute and all that data. So there you have it. That's the recipe. Massive compute, vast data, and groundbreaking algorithms. So now, let's look at the incredible results of that recipe, these wild new frontiers that AI is pushing into. And the impact isn't just in one little area. We're seeing it ripple across basically every domain you can think of, from deep scientific research to our creative work, and even to the physical jobs that make up our daily lives. In the life sciences, for instance, AI is becoming this absolutely essential tool for discovery. You have models like AlphaGenome that can actually look at our genetics to pinpoint disease risks. Meanwhile, other systems are analyzing blood cells for signs of illness with an accuracy that's even better than human experts. AI is also turning into a really powerful creative partner. You've got models like Veo for video, Imagen for images, and Lyria for music, and they're all generating totally new content from simple text prompts. In fact, some recent studies have found that advanced AI can now outperform the average person on certain standardized creativity tests. Wild, right? And this isn't just happening in the digital world. Embodied AI is learning to interact with the physical world. Gemini robotics can perceive its surroundings, reason about them, and actually use tools. At the same time, you've got AI agents like Sima 2 learning how to be helpful teammates inside of complex video games. So here's the most crucial point. We are not just seeing small, little improvements here and there. What we're witnessing is a fundamental acceleration of our ability to solve problems and to create. This quote from Google DeepMind says it all. It could speed up discovery by 10 times, 100 times, or maybe even more. This explosive, exponential growth, it really feels unstoppable. But can it actually last forever? What kind of challenges are starting to pop up on the horizon? Yeah, the path forward isn't quite a straight line. As you can see here, there are some major headwinds. We're starting to hit a compute wall, the insane cost and physical limits of building bigger data centers. There's a real concern about data scarcity. We might actually be running out of high-quality human-generated data to train on. And of course, there are huge ethical hurdles we have to navigate. But on the flip side, there are these powerful tailwinds pushing us forward. Future breakthroughs like more efficient algorithms, brain-inspired neuromorphic chips, and the truly mind-bending potential of quantum AI, well, they could just rewrite all the rules again. This tension between the incredible potential and the serious risks is why the whole conversation has started to shift. The ultimate goal for many leading researchers isn't just about building more powerful AI. It's about doing it responsibly, to make sure this unbelievable technology actually serves a positive purpose for all of us. And that leaves us with what is maybe the most important question of all. And it's not a technical question anymore. It's a question about our own values and our vision for the future. We have successfully built machines that can learn, reason, and create. The question now is, what do we teach them?